Yeah, okay. So today's topic is domain and range. This is lesson number 1. You can just feel free to interrupt anytime if there is anything that's confusing, okay? Now, so domain is defined as the allowed, this is my definition, allowed X values. And something's beeping. Anyone hear that?
No.
There's some beeping sound from someone. I think that's coming from Sam.
Oh, it might be the fan on my laptop.
Yeah, would you be able to turn that off?
No. So I can mute myself and unmute if I need
Okay, so maybe I'll mute you, and if you want to ask any question, you can just unmute yourself.
Yep.
Yeah. All right, and range here is given by allowed Y values. So, for example, if I have Y equals to X squared, you guys probably have seen, Sam, you can also reply through the group chat if you don't want to use the microphone. So y equals x squared. So this is the most basic form of quadratic equation. So this is the graph, and the domain is x. We write it like this: x is an element of this set, negative infinity to infinity. So there must be actually a bracket like this. So this symbol here, you should write it down. This symbol here means element of. And, you guys all know what infinity means, right? So think about this. We can actually plug in any number into the x, right? So the domain, or the domain, which is the allowed values of x, is basically infinity to infinity. So this is the domain. Alternatively, so we say that x is an element of this set. Alternatively, we can say x is an element of all real numbers. So this capital R means real number. Okay, so there is something called imaginary number or complex number. That's capital C. This is a complex number, but we're not talking about that. So real number is any number you can just imagine. It includes pi, which is like 3.14 blah blah blah. It includes 1.3333 forever. It includes 1.5, 2, -1, 0. So these are all real numbers. Even square root 2, that's also a real number, okay? So we can plug in any number into the x, so that's why the domain for this function is like that. Or we can say x is an element of all real number. Another way of writing the domain is x is between infinity to negative infinity. Does everything make sense so far?
Yep.
So we've got Ashwini there as well. Hi, Ashwini.
Hi, sorry.
Long time no see. Yeah, so we're doing domain and range. So I'm not sure, Ashwini, if we did domain and range during private lesson.
I don't think so.
Don't think so? Okay. Anyway, so this is how you write the domain for this one here. Let me know if you guys have any question. So we can write x is between infinity and negative infinity. Okay. Now, can we do x is between, perhaps you guys have seen this one, less than or equal to negative infinity. Can we do that or not? I want you guys to answer that, true, false. Here, so log on to Socrative and just try whether you think it's true or false. The question was, can we write the domain like this with an equal sign there? So a lot of you are saying it's true, but the answer is actually false. So Ashwin, you can also log into, have you received my email instruction about Socrative, Ashwini?
Just reading it now.
Okay. So all you have to do is just download Socrative here and type in the classroom name, MathBridge. Okay. So that's, what sort of phone do you have, Ashwini?
iPhone.
iPhone. So go to App Store, type Socrative,
Yeah.
student, and then type in the classroom name, MathBridge. So you don't need any ID or password. So I'm going to explain to you why this equal sign is not allowed for this infinity. The reason is x can never equal to infinity. Infinity is something that keeps on growing. So therefore you can never, a number can never equal to infinity. That's why we always use, whenever there's infinite sign, we always use this inequality sign without the equal sign there, okay? Now, we're going to talk about range. By the way, this one here is the same thing as this one, right? Now, this one here, of course, is not allowed to, you're not allowed to write like that, but it's equivalent to x is an element of square bracket rather than round bracket. So do you see the difference? So if you have that, that's the same thing as this one here. And if you see, this, or how do I write it? Yeah, so the square bracket is inclusive bracket. So these two is inclusive bracket. This is exclusive bracket. So that means it does not include that point. So for example, if I have x between 3 and 1, then we write x is an element of 1, 3. If x is 1, it can equal to 1, but less than 3, then we write it as, let's give it a go. I want you guys to type in your answer on over here. So you can just type your answer. So x is an element of, I want you to fill in the blanket here, please. Bracket, yeah, this empty bit here. Bracket, not blanket. Okay. So let's have a look at the answers. I've got 3 responses. Let's have a look. Okay. So none of these are correct. I want you to think about this. Because these are your answers, but this is partly inclusive. This is exclusive here. So it must be like this. 1, 3, round bracket. So this means this here. Okay? So pretty simple, right? Now, I hope that makes sense. Now let's think about the range. So range is the allowed values of y. So if you have this function, what's the domain for the range? So that's all of the, it must be an interval that includes all of the values of y here. Okay, so I'm going to give you 3 response questions for that as again. So I want you guys to try. So type your answer for maybe this this bracket over here. Okay. So fill in the blank there. So of course there are 3 ways of writing the range, just as there are 3 ways of writing the domain. Here, what you can write y is between something. So you can do anything you like, all right? So just by looking at this diagram here, this graph here, you guys can just try, okay? Okay, so I've got 2 answers. So one person is saying infinity. So I think you guys should do a little bit better than that, okay? So maybe try again. This one looks pretty good. 0 to positive infinity. Okay, but that should be a round bracket, isn't it? So well done to this person. Who is this person? Do you want to identify yourself? You don't have to. Was it Ashwini?
Yeah.
Okay, well done. So the answer is, it's starting from 0 here, isn't it? And then it's going up. So there is no, the y value is not going to be any negative value, right? So it is from here to infinity. Whereas the domain was from here to here, right? You see the technique? From left to right, that's how you find the domain. That's negative infinity to infinity. Of course, we cannot confine this graph. This graph goes on forever like this. That's why it's from negative infinity to infinity. But for the range, it's from there to there, right? So that's infinity. So it must be 0 to infinity, but you have to do exclusive for infinity, and it has to be inclusive for 0 because it includes that point there. This point is 0, 0, isn't it? Now, another way of doing this is, it's a little bit complicated. So this is actually a lot simpler. So I want you guys to try this one on Socrative here. So I'll give you a few seconds for that. So try this, this bit here. So y is between. So you have to literally type something like this. Like, now if you want to use the equal sign, you can use this one. Can you see this symbol here? So you guys can type that, right? So you guys can do this and this. That's the same as this one here, okay? Or you can do this and this. That's the same as this one. Doesn't matter, okay?
Sorry, I'm a little bit lost.
Okay, so we are trying to, you see how this one, Valerie, can be translated into this one, right? So it's just the same thing, just different way of writing it, right?
Oh,
So
right.
we try to write this one in this form, like this.
Right.
Okay, so y is less than something, greater than something, okay? Obviously, I think 0 should go there, and something else goes over there, okay? So let's check the answer, guys. Oh, no answer yet. No one has answered yet. Okay, who's finished?
Yep.
Okay, we've got 4 answers there. So y is equal to r. So this is the correct answer. Well done to this person, whoever that is. So this one is almost correct, this one here, because you can see that there must be an equal sign, right? Because in this case, it includes the 0. So there must be an equal sign there and infinity there. So this is the correct answer. Well done, guys. So that's basically a little exercise on domain and a little lecture on domain and range. So we're going to try some questions here. Oh, need to mute that. Okay, so this is a booklet from Narrabundah College. So there's domain. So domain is allowed X values. So don't worry about what's in there. It's a little bit more advanced than what we're doing now. What we need to do next is, so let's have a look at these questions here. So these are some examples. So it looks a little bit complicated, but you guys have to get used to this way of doing math, because in year 11 this will become the norm. Okay, so all this means, so A, so you need to understand that this curly bracket, whenever you see curly bracket, it means a set, okay? So I'm going to give you a few definitions. If you have this symbol, this means set. This means element of. This dot dot means such that. And this symbol here means subset of. Slash means except. This here, upside down A, it means for all. And sideway reflected version of E means there exist. So this A is for this A. It's not a coincidence. We just made it, mathematicians made it like that, you know? So that means for all. And if you have I, F, F, this means if and only if. What else is necessary? Yeah, if you have coordinates, you guys know what coordinates are, right?
Yep.
Okay, so you guys are all copying down, right? Okay. So we're going to look at this one here. So A literally means this. Set. So why is it a set? Because you got this curly bracket there. So we got, I'm just gonna rewrite it here. So this is read this way, a set of coordinates xy, coordinates xy, such that, that's this bit here, such that y equals x squared. So what does all of that mean? So that's how you read this one. So a set of xy coordinates, or coordinates xy, such that y equals x squared. So this literally means in year 10, you guys learned this as y, simply just y is equal to x squared. Okay? Or function f of x is equal to x squared. So I want you guys to just say true over here if you have seen this one. Of course you have, maybe, I don't know. So go for true if you've seen this one. The bottom one here, f of x is equal to x squared. False. So 2 of you have not seen it. Okay, so 3 of you haven't seen it. So I'm going to explain it then. But let's do another survey here again. Have you guys seen this one then? Y equals x squared. True or false? Go for true if you have seen it. Go for false if you haven't seen it. Okay, so 2 trues and 2 false. That's a bit interesting. Okay. So let me just go through these two first. All it really means is that you know, this is y equals x squared. So when x is equal to 1, y equals 1 squared, which is 1. When x is 2, then it's 2 squared, so it's 4. 3, then it's 3 squared, it's equal to 9. And 4, then it's 4 squared, it's equal to 16. So if you plot all of this, well, when x equals to 0, y equals to 0 squared, so it's equal to 0. So that one there will be here. 1, 1, that's actually here. 1 and 1. And then 3, then 9, right? So 3, then 9. X equals 3, and then y equals 9. Now we've got to do it for 2 and 4. So 2, then 4. 3, then 9. So that's why it grows like that. So that's a parabola. That's the equation of y equals to x squared. F of x equals x squared is just another way of writing y equals x squared. So it's not a different thing. So what we do is we say that f of 1 is 1 squared, which is 1. F of 2, so when x is 2, you plug in 2 into the x squared, so it'll be 2 squared. Before, f of 3 is equal to 3 squared, so that's equal to 9, etc., etc. So what does f of, so why do we sometimes write something like that as function of x? The reason is, so we can, so what that means is this, so f of x, what's the meaning? So you often see this thing, right, in maths, throughout this year and next year as well. The meaning is this. It's simply the y. You see how this one was replaced by f of x? So f of x is simply equal to y value. It is y value, okay? That's the meaning of f of x. But it is y value when, let's call this one 3 there. What's f of 3? It's the y value when x equals to 3. So the meaning of f of x is this. It's the y value when x is x. Okay? So let's say I have f of x is equal to x squared plus 2x plus 5. Let's plug in 1 here. Then what do I get? The answer is 1 squared plus 2 times by 1 plus 5, which is equal to, that's 1, 2, 5. So the answer is 8. So what's the meaning of all this? We say that the y is 8 when x is 1. See, what's the meaning of this one here? That's the value of y when x is 1, and that's 8. Okay, so that's why we have this one here. Don't that all make sense to you? Now we're going through set notation. So after today's lesson, I'm going to, like after the tuition, I'm going to ask each one of you how you guys went in today's lesson. So if, let's say, everyone found it really, really difficult, then I'm going to lower down the level a little bit, okay? But if everyone found it okay, then I'll keep the level, all right? So it'll really depend on how you guys went today, okay? Now, so we're back to this one. Obviously, the domain, we already did domain and range for this one, right? Let's have a look at C. Okay, so C is very simple. What's the domain? So let's actually think about what that means. Okay, so it's a set of coordinates -2, -1, -1, -1. So it doesn't actually tell us any rule. It just says that it's a set containing all these coordinates. All right, so you got -2, -1, -1, -1, -1, 1, 0, 1, 1, -1. So if we plot this one should be around here. This one should be around here. That one should be about here. 0, 1 is around here. That one there. And that one there, 1, -1, is around there. So let's talk about the domain. The domain in this case is not going to be, so it is going to be x is an element of, so just watch this, -2, so that's x value here, -1, there's another -1 there, so just put all the x values there, okay? 0 and 1. Now, this is quite different from writing the domain, like, for example, like that. If you write it like this, that means x is between 1 and 2. That means x can be any value between 1 and 2. X can be 1, 1.1, 1.2, 1.111, 1.001, anything between the 1 and 2. But question C here is a little bit different from question A because you have these, you got only 5 coordinates there, right? This. Let me zoom in a little bit there. Yeah, you only have the 5 points there, okay? So you only need to take these 5 points. So X is an element of set containing set of -2, -1, -1, 0, and 1. Okay. Now, let me give you a question. Should we do, because there's -1, -1, should we just do -1 once or twice? I want you to go for true, go for false. If you think this is right, go for false, right? It's a pretty simple question. Okay. Okay, so it's a 50-50 for you guys. So the answer is actually false. You don't have to repeat the domain more than once. If it's already mentioned, then that's it. So that's going to be the domain. Okay. So using this knowledge, you guys can maybe figure out. All you have to do is just give a list of the values of y. Okay, so I'll try that question here. Okay, so the answer is -1, -1, 1, 1, -1. So I think it's just -1, 1. Very good. Yeah. So, yep, that's very clever. So someone put E there because that looks very similar to this one here, right? So y is an element of, so this is the best answer there, -1, 1. So this does not mean the domain is from -1 to 1. You see how this curly bracket is not round bracket? Only the round bracket and the square bracket means it's from there to there. If you have curly bracket, it just means it's just that and nothing else. We're going to look at D now. So I want you to look at D. This is equation of a circle. So this is read this way. Set of coordinates x, y such that x squared plus y squared equals to 1. You will learn this one probably this year. But they should teach you this in year 10. But otherwise, you're going to learn that in year 11. But we're just considering the domain and range. So this is equation of a circle. And this is 1, -1, 1, -1. So I want you guys to write the domain and range in any way you want. So you can write it like this, or you can write it like this. Doesn't matter. So you guys can try that as well here. There we go. So this one here looks like that. So if this is your graph, what is going to be your domain and range? So I've got one answer. So I'm not sure if this is, so you have to use either square bracket or round bracket. So if you have a curly bracket, it means it's just that value and that value only, not anything in between, right? But very close. Okay. that's very good. So this one is, yep, so y is element of -1 to 1 inclusive. X is also -1 to 1 inclusive. So this is the correct answer. So this one is exclusive, right? But the circle actually includes that point, right? It includes 1. So it must be like this. It's -1 to 1, -1 to 1. This is 1, -1 inclusive. So same thing. This is the same thing as this one. And y is inclusive 1 and -1. All right? Like that. So I hope that makes sense to you. Okay. We're going to try F here. Let's try F. Have you guys all done straight equation of straight line? Let's do some survey there. Just go for true. If you have done it, the y equals to mx plus c. So this is gradient, right? This one is the y-intercept. So whatever this is, it looks complicated, but it's read as this: a set of coordinates xy such that y equals to 2x minus 1. So that means that's the main thing that you have to give your attention to. And there they put a comma there, and then they define the domain. All right. So let's say we don't have anything else, but we just have this. So usually, you'd be just in year 10, you'll be just given that. And all that really means is that you have this xy coordinates. The gradient is 2, so it's positive. So it is some graph that's going up. Anything that's like that, or like that, or like that, that has positive gradient. If this is a negative gradient, then it'll go down like this, okay? Like this, or like that, or like this, you know? So it's very simple to draw this thing. So you have -1, that's the y-intercept, so that's -1 here. And it's got positive gradient, so it just rises like this. And we can figure out what this point is. This is also a very important point because that's x-intercept, this is y-intercept. If we simply let the y equal to 0, because on the x-axis, y value is 0, so you have 2x minus 1, and if you solve this plus 1 both sides, you get 2x, x is equal to 1/2, so you have, this is a 1/2 there, okay? So this is the graph, but we want to draw this function. As you can see, if you only have this one, then you just draw the straight line like this, and it just stretches up forever, stretches down forever. So the domain is basically infinity to infinity. Y value is also infinity to infinity. However, we have this situation here where they define the domain to be 2 inclusive to -1. So that's our domain. So the domain is restricted by this rule here. So this is read this way: set of xy coordinates such that y equals to 2x minus 1 and x is an element of -1 to 2 inclusive. So all we have to do is, all right, so where is x equals -1? This is x equals to -1. Where is x equals to 2? So 2 is somewhere around there. So we cut this function over there, and we cut the function over here. So the line doesn't stretch out to infinity. It is just only from there to there. Now we can find what the y coordinate is for this one. We plug in 2. Simply, this is just a rule that tells us what the y value is whenever you know what x value is. So you plug in 2 there. 2 times 2 is 4. 4 minus 1 is 3. So this is 3 here. You plug in -1 in here, so it's -2 minus 1. That's equal to -3, so that's -3. Okay? So we can figure out the domain and range. So for this thing here, the question was, what is the domain? What is the range? Well, domain is simple. It's just given here. Domain is from -1 to 2. Range is from, you guys can tell me. Can anyone tell me? It's from, so without doing subtractive, can anyone tell me?
-1 to -3.
-3.
Or -3 to -1.
It's from here to here, isn't it?
Oh, -3 to 3.
That's right, -3 to 3. -3 to 3. So that's the answer for the range. Okay. One more thing we're going to go through is, so if we just go back to this stuff over here, okay? When we have this function, we write the domain as this, or this, or this, right? So it all makes sense. Now, we have this and this, so these two are the same thing. And there's another way of writing the range for y, this way here. So we say it is all real number positive. Because you can see that the y value starts from 0 and it's upward, right? So we write range is, you can see that it's always going to be positive value, right? Because it's from 0 to positive infinity, so it's all positive value. But this does not include everything. What's missing here? So you might be a little bit confused. So this means any number, okay? Any real number. This here, R plus, means any positive real number. So this does not include the negative numbers, okay? But obviously 0 is missing from here, right? So what we do is we put set containing 0, and then we put a union sign. The union, so that symbol there, union. Okay? Now, I think we're ready to do some more questions. So domain and range is like the very first topic that you'll learn in year 11, and lots of students get confused when it comes to domain and range. And even year 10 students can learn this stuff, but they just delay it until year 11. Now, we're going to do move on to next idea. So this one is pretty simple. So we're talking about the function notation. So this here means y equals to 2x squared plus x. And we just choose to write the y as function f of x. Now if you have f of 3, all you have to do is just plug in 3 there, okay? So I get 2 times by 3 squared plus 3. 2 times by 3 squared plus 3, okay? So that's equal to 9. 9 times by 2 is 18 plus 3, so that's equal to 21. So I want you guys to try f of -2. You just have to plug in -2 in here and here. And try f of x minus 1. And try f of x minus 1. So what's the difference between these two? Okay. So I'll give you free response here. So work it all out in piece of paper. And all you have to do is just type your answer separated by comma. Okay. So the answer for this one, answer for this one, answer for this one, just put your answer like this. All right. Well, actually use a semicolon like this. That's right next to, that's near the enter button. So just above the full stop, you'll see the semicolon mark, okay? Okay, so no answer yet. If we plug in -2 there, 2 bracket -2 square plus -2, that's what you have to do. And if you plug in x minus 1 in here, so whatever is in the bracket, you plug that into the x. So 2x squared plus x, right? That's what it is. And you plug in x minus 1 and x minus 1. So if you leave your answer like this, I'm going to consider that as correct. You don't have to expand it out. Now, as for the last one here, I'm not sure if anyone submitted the answer, so we'll just do it here. Don't worry about the Socrates. So this is f of x minus 1. So we have all we have to do. This is f of x, and you see how the -1 is outside of the f of x. So all you have to do is, all right, x squared plus x. That's this whole thing, f of x. And there's -1. Just have to put -1 in the end. Simple as that. Okay. But there's a huge difference between this and this. Right. So if you have f of x, remember f of x is equal to like x squared, like ln of x plus sine of x. You guys may not know what that all means. If you have f of star, then that means it's literally star squared. Replace the x by star, you know? ln and then star. plus sine of star. Now, if you have f of triangle plus 1, then you have to replace the x by triangle plus 1. So that's triangle plus 1 square, and then ln of triangle plus 1. Of course, there must be a bracket there because there's a plus sign. Otherwise, it'll be a different thing. And then sine, and then you have to put a triangle plus star, triangle plus 1. Okay, so that's how you deal with these function symbols. Okay, now, I want you guys to try this one. So I'm going to do the first part for you. You can do the second part on Socrative. So the Socrative is still live there, right? So let's do the first bit there at -2. So f of -2, that's 2 times 1 minus 2 plus 1. So that's equal to -4 plus 1, which is -3. So what is f over 1 over a? You do this one. Okay. What's 1 over f of 1 over a? Okay, so people are still working. I haven't got any response yet. Oh, I've got one there. Let's see. Still one answer. So just need to plug in 1 over a into x. So you get 2 times y, 1 over a plus 1. So you can simplify this as 2 over a plus 1. So in the Socrative, you could answer this as 2/a plus 1, right? Yeah, so 2/a plus 1, that's fine. 2 times by 1 on a. Yeah, that's all fine, that's all fine. That's all good, okay? All right. So we can call it a day here. So this was our first lesson, and I'll talk to you guys all individually, like tomorrow, and get some feedback from you guys. And after that, we'll decide on what we should learn next week. And you guys will find homework. I'm going to upload homework here. So you guys will have to send me a message or send me an email with your mobile number and